Hello, students. I understand that there's a little bit of confusion with with one of our assignments here. This one in particular, uh, Bohr models, ions, and isotopes. I completely understand that. If you're not here, you're not hearing the conversations, you're not hearing the discussions, so it's a little bit difficult for you guys, and I get that. So I'm going to go ahead and just make a little video for you to kind of go through each section of this and show you what I'm looking for. Okay, so Bohr models, ions, and isotopes. So these right here are Bohr models. Bohr models show us really the location of electrons in a atom. So an atom, sorry. And also we know that we don't really have to do too much with protons and neutrons as far as configuring them. We just know that they're all kind of bunched together in the nucleus. So let's look through each of these. First off, let's take a look at this. Since I did this part kind of together with the class, Bohr models are used to represent the protons, neutrons, and electrons that make up an atom. Well, clearly, protons, neutrons, all the electrons always are outside of the nucleus. So yes, it is. That's true. It does represent protons, neutrons, and electrons that make up an atom. Bohr models are, yes, this one's also true. Bohr models are the most current model of the atom to date. Okay. Niels Bohr did develop the Bohr model. That's also true. Bohr models are to scale with real atoms. Well, that's clearly not true. Real atoms are not visible to us, and these are very visible. These are just really blown up versions, so they're not to scale. So that one will be false. And again, we did do all these together in class, so that's why I'm just kind of giving you the answer. It's almost like a little mini lesson. So Bohr models help to represent the different energies of electrons, which is true. They're in different energy levels, right? N equals 1, N equals 2, and N equals 3. So we got true for number 1, true for number 2, true for number 3, false for number 4, and true for number 5. So on this one, you're simply identifying the element that each atom here represents. And the way we do that, remember, is the protons equals the number of protons equals the atomic number. Okay? I'll do one of these. Okay, and then you guys at home kind of need to do it yourself. So we know the number of protons equals the atomic number. And here we have protons are 7. So let me real quick, I should have already had this open, sorry. I'm going to open up a periodic table from Google Classroom where you guys can also find yours so you can watch me do this, and maybe that'll jog your memory that you will find your periodic tables inside of the assignments. You have a different view than me, so periodic table right here. So again, that last element we were looking at, that last atom, has 7 protons. So we know its atomic number is 7. We go to the periodic table, we find, okay, here's 1, 2, 3, 4, 5, 6, 7. So that's nitrogen. This atom is nitrogen. So all you're going to do is, using CAMI, since this is a PDF, type nitrogen right here. That's all you got to do. And then do the same for B and C. Find what element this is, find what element this is. So then you also need to determine, using these atoms, A, B, and C, whether they are ions or neutral atoms. So if they're ions, that means they have an unequal number of protons and electrons. So it would have either a positive charge or a negative charge. If they are neutral, that means they're going to have an even number of protons and electrons. So if they have the same number of protons and electrons, you know that they're neutral. So obviously all 3 will be the same, or else you wouldn't just be circling one option. So find out what that is. There is a typo right here on G, because the 3rd energy level can fit up to 18 electrons. I know I said we weren't going to work outside of N equals 2, but it kind of seems like we're going to have to based on these worksheets that I've put together here. So it's not a big deal. You can fit 2. Well, I'm just going to give you a refresher. Here's just giving you the answers to E through G here. You can fit 2 electrons in the 1st energy level, 2. You can fit 8 electrons in the 2nd energy level. And then again, a typo down here. The answer is 18, so just circle 8. And then tell me which level would fill first. Okay, so remember, we talk about how energy levels go from the inside out. That might have something to do with the order they fill up in also. Okay, down here you want to make neutral Bohr models. Neutral atoms, that means they have an equal number of protons and electrons. So you're going to find the atomic number for sulfur. Again, I'll just do one with you. The atomic number for sulfur. So kind of just go across until you find sulfur. Here it is. It has an atomic number of 16. That means it has 16 protons. So you'd come back here and you'd put 16 right here. You're going to make this the same number. This N is for neutrons. We'll get into those soon. Neutrons equal 16. They're going to be, just make them the same. So you also need 16 electrons. You'd fill in this shell with 2, the first shell. You'd fill in the next shell with 8. So we need to max those out, and that gets us to 10 electrons, leaving only 6 to place on the outside shell. Okay? So you're going to put 6 on the outside shell. And I'll let you guys do magnesium and argon yourselves. I have my eye on you. What a good joke. What is an ion? Well, we've said this several times, but I'll say it one more time. An ion is an atom that has either a positive or negative charge. That means that it has an uneven amount of protons and electrons. So it either has more electrons or less electrons than protons. So here it wants you to draw a Bohr model of sodium. So you're going to draw your nucleus, and then you're going to draw your energy levels around it. You don't have to draw any more energy levels than needed. There's no need to draw an energy level if there's no electron in it. Okay, so sodium, I'll give you a hint, that's got 11 protons. That means it's the 11th element. So you can start that off, give it 11 protons, give it 12 neutrons, make it neutral, give it 11 electrons. So everything's the same in a neutral atom. 11 electrons, 11 protons. Neutrons can be different, but we'll get there. Here it wants you to give me a sodium atom with a positive charge. So that means you will need one more proton than electrons. Now remember, we cannot take away protons because sodium will no longer be sodium. If we took away a proton from sodium, it would become the 10th element, which is neon. So you have to actually take away an electron, okay? So you're going to have 11 electrons, or protons, I'm sorry, and 10 electrons here. That should tell you what you probably need to do with the anion, which is the negatively charged atom. Same concept with the next two for carbon and aluminum, okay? Now, this one talks about isotopes. Just like I did in class, I'll give you the definition of an isotope. An isotope is an atom that has an uneven amount of protons and neutrons. Normally, we're going to see more protons than neutrons. That is something that is naturally occurring. Remember that I said that when you're doing this worksheet. Isotopes are naturally occurring. They can be made in labs, and some are that actually contain fewer neutrons than protons. That doesn't happen in nature very often, I'm pretty sure. I'm not a chemist, but I do know enough about it to tell you that they are naturally occurring, and we do find some of these versions in nature. So let's go through the first one here. We have 16 up here. This is actually notation for an isotope, okay? Normally, when you look at a periodic table, you're going to find the atomic number up here on this side. But when you are doing notation for an isotope, you actually put the atomic mass up here and the atomic number right here to the left. Okay? So this means that the atomic mass is 16. Well, we get atomic mass by taking protons plus neutrons. So 8 plus something equals 16. 8 plus 8 equals 16. So that means that this one right here has an equal number of protons and neutrons. It's not an isotope. It has an equal number of protons and neutrons. But this one has 17 for its atomic mass with 8 protons. 8 plus something equals 17. 8 plus 9 equals 17. So this one here is an isotope. It's got an uneven amount of protons and neutrons. Same for this one. 8 plus something equals 18. Well, 8 plus 10 equals 18. So this one must have 10 neutrons and 8 protons. So over here you would say oxygen has 8 protons. Oxygen's atomic number is 8. Oxygen 16 has 8 neutrons. Oxygen 17 has 9 neutrons. And oxygen 18 has 10 neutrons. Do the same thing for nitrogen and carbon right here. So an isotope has a different number of neutrons than a normal atom. Isotopes are, think back to what I just said earlier. I'm not going to give you that answer. It's one of those two, but I'm not going to give it to you. If you were listening, you should know it. An isotope's something, is it its atomic number or its mass number that's different than what you would expect looking at the periodic table? Remember the rule for the atomic number and protons. I'll just ask you this question to give you a hint about number 3. Can you change the number of protons and have an element stay the same element? And number 4, when isotopes are formed, their atomic mass or their atomic number changes. It's kind of the same thing here. Can you change the number of protons and it remain the same element? All right, here you're drawing a Bohr model of hydrogen. And this is just a neutral Bohr model of hydrogen, so it's just regular hydrogen. Hydrogen is number 1 on the periodic table, so we know it's got 1 proton. If it's neutral, we know it must have an even amount of protons and electrons, because in this case, 1 minus 1 equals 0, and 0 is neutral. So you're going to want to draw a Bohr model of hydrogen, so you'll need just a little nucleus that says, tells me that I've got 1 proton and 1 neutron, and then it will have 1 electron. But here we're drawing isotopes. So hydrogen dash 2, if you write it all out like that, that means we've got an isotope of hydrogen. So hydrogen has 1 proton and it has 2 neutrons in this case. Hydrogen 2 means it's got 2 neutrons. It's an isotope. It has a different number of protons and neutrons. So if hydrogen 2 means it's got 2 neutrons, what might hydrogen 3 mean, you think? Give that one a try on your own. How many neutrons will hydrogen 3 have if hydrogen 2 has 2 neutrons? Remember, the protons will not change. All right? And here, when it says this is a blank atom, I want you to look at the number of protons, which will help you determine the atomic number, and then you write the name of the element here in number 1. Okay? Here you're going to tell me how many protons this has, how many neutrons it has, and then count the electrons. Tell me how many electrons it has. By now, we should know how to get the charge of an atom. You take the protons, number of protons, minus the number of electrons, and that gives you your charge. If it's a negative number, you have a negative charge, and it's an anion. If you have a positive number, it's a positive charge, and you have a cation. We're not really worried about anion and cation here in this problem, so just tell me if it's an ion. Is it an isotope? Remember, what makes something an isotope? Well, if an atom's an isotope, that means it has a different number of protons and neutrons. So do the same for number 9. And here you're going to create an element that is both an ion and an isotope. So that means it needs to have a charge, either positive or negative. I don't care which one you make it. And it needs to be an isotope, so it cannot have the same number of neutrons. So you can pick an easy one. You can pick one of the first few atoms. Like you got hydrogen as the first atom, then you got helium as number 2, lithium's number 3, beryllium's number 4. Pick something easy like that. And make me a positively or negatively charged atom. That makes it an ion. And then give it a different number of neutrons, which makes it an isotope. You can pick any element you want. I would pick one in the first I'd say probably 16, just to make it easier on yourself. Okay? So hopefully that clears up some of your questions that you may have on that assignment. Feel free to email me if this isn't clear enough. I'm going to continue to make videos for you guys for lessons and to explain complex assignments like this one. Okay? So y'all have a good day. I hope to see you back here.